Hello everyone, my name is Meng Wang. Now I'm recording the first two questions of homework 5 of probability and stochastic process. Now let's look at the first question. X and Y are independent with the density function of X and Y, and Z is equal to X plus Y. Find Fz by first convolution method and second geometric method. First, let's use the convolution method. The convolution method is expressed by this expression. So we just apply the expression of fx and fy into this equation, and we separate each term. We can get the equation like this. We separate the integral by each term, so we have 1, 2, 3, 4, have 4 terms in total. Now let's look at the first term. The first term, the range of alpha is greater than 0 and less than z minus 1 for these two functions have meanings. And because when alpha is greater than 0 and less than z minus 1, if we multiply them by a unit step function of z minus 1, the value will not change. So this term is equal to this one. Similarly, we could get the following 3 terms. We could also multiply them by the unit step function based on its individual range of alpha. So the second term is u of z minus 2, and the third one is u of z minus 2, and the fourth one is u of z minus 3. And then we calculate the 4 terms and calculate them together. We could get this expression. And then what we do is to draw the pictures. Now let's look at the first term. Z minus 1 times unit step function of z minus 1. This function is this line. And it minus z minus 2 times the unit step function of z minus 2. This function is this line. So this line minus this one, we can get this one is kept, and yeah, we can get this. And then we minus the third term, z minus 2 times unit step function of z minus 2. So it's still this line. This one minus this one, we could get the diagram like this. This part, this triangle, and this line. And then finally, plus z minus 3 times unit step function of z minus 3. U minus 3 is this line, so we just add them. This one add this one, we could get the final diagram is a triangle when x is greater than 1 and less than 3, and otherwise it's 0. So the final expression of fz is when z is greater than 1 and less than 2, the expression is here, z minus 1. And when z is greater than 2 and less than 3, the expression is minus z plus 3. Otherwise, it is equal to 0. Second, let's look at the geometric method. The range of x and y is x is greater than 0 and less than 1, and y is greater than 1 and less than 2. So we draw the range of x and y in coordinates like this. This is from 0 to 1, and this is from 1 to 2. this is the range of x and y. It makes a square. Yep. So z is equal to x plus y. X plus y is a line. It moves like this. So we have to discuss the range of z because it will covers a different area of x and y. For z is less than 1, which means the line is no greater than here. So the area it interacts with this square is 0, so fz is 0. For z is greater than 1 and less than 2, which means the line is like here. The area they have in common is this triangle. So it's 1/2 times z minus 1. This length is z, this is 1, so this length is z minus 1, and here is also z minus 1. So it's the common area is like this, which expressed like this way. And when z is greater than 2 and less than 3, it's like the line is like this. The area it has with the xy square in common is this part, and this part is equal to the big triangle minus this 2 triangle. The big triangle is 1/2 times z minus 1 square, and the 2 mini square is 1/2 times z minus 2 square and times 2. It's the 2 small triangles. The final expression is like this. And when z is greater than this point, which means here is 3, so when z is greater than 3, fz equals 1. So based on the above discussion, we could get the density function of f is the differentiation of distribution function of z, which means when z is greater than 1, less than 2, density function of z is z minus 1, and when z is greater than 2 or less than 3, fz is minus z plus 3, otherwise it's 0. Okay, we finished the first question, and now let's look at the second question. Given the joint density function of x and y is equal to a over x times y squared when y is greater or equal to 1 and x is greater than 1 over y less than y. First, draw the non-zero definition region of density function of joint density function of x and y. Based on the information given in the question, y is greater than x. Y equal x is this line. It's greater, so it's the above part. And y 1 over y is less than x. Y equals 1 over x is this diagram. It has another part in the third quadrant, but we should notice that 1 is greater than y is greater than 1. So for y is greater than 1, we only have this part. So the common part, the non-definition region of density function of fxy is the shaded area. For the second sub-question, find a so that density function of x and y is a valid joint density function. The definition of a joint density function is that the integral of it from -infinity to infinity equals 1. So based on this definition, we could get this expression, and we substitute fxy with a minus y squared times x, like this. And the range of y is from 1 to infinity. We draw a line y here. And the range of x is 1 over y, and the upper bound is y. So here is like this. So by calculation, we could finally get the value of a is 1 over 2. For the third sub-question, find and draw the marginal density function fx and fy. Fx is equal to the integral of fxy dy from infinity to infinity. To calculate the expression of fx, we should discuss the range of x. So first, let's look at the first range when x is greater than 0 and less than 1. The range of y, the lower bound is 1 over x, and the upper bound is infinity. So the bound is like this. And for the second part, when x is greater than 1, is here. We draw a vertical line, and it's easy to see that the lower bound is x and the upper bound is infinity. So the final expression is 1 over 2 times x squared. Now let's look at the density function of y. For y, it's the integral of fxy dx when x is from infinity to infinity. We draw a horizontal line here, and it's easy to see that the lower bound is 1 over y and the upper bound is y. So the bound is like this, and we could get the final expression is line y over y squared. Otherwise, it's 0. And we have to draw the diagram of x and fy. Fx is very easy. The diagram is like this. And for fy, we have to differentiate it twice to get some turning points. Like for the first order of its differentiation is when y is equal to e to the order 1 over 2, fy comma means 0, which means when y is less than e to the order of 1 over 2, fy is increasing. And when y is greater than it, fy is decreasing. And the second order of differentiation of fy is to describe the diagram more detailed, whether it is this way or this way. Okay, let's look at the fourth sub-question. Verify fx and fy are valid density functions. A valid density function means the integral of them from infinity to infinity should be equal to 1. So let's first look at fx. Fx dx, the integral of it we have got its expression is like this. So from 0 to 1 is 1 over 2, and when it's greater than 1 is 1 over 2x squared. So it's 1 over 2 plus 1 over 2 is 1. And for fy, when y is greater than y, the expression is ln y over y squared. The final calculation also equals to 1. So definitely fx and fy are valid density functions. That's all. Thank you.